Welcome back to another lesson in MCV4U. Today we'll be talking about the equation of a tangent and continuing our exploration on what that means in terms of calculus. So if we look at this first example, it says a publishing company determines that the cost in dollars for publishing X copies of catalog is represented by this function, c of x is equal to 500 plus 2 square root x, where the rate of change of the cost c with respect to the number of catalogs x when x is equal to 400. So here it provides us with an x value of x is equal to 400. Here, if we sub in our value into the equation, so c of 400 is equal to 500 plus 2 square root 400. Here we see that our answer would be 540. So here we can see when there is 400 catalogs, it will cost $540. Okay. For now, we're looking for the rate of change. So we're looking for the rate of change, or we can also understand that to be the slope. Slope of the tangent. Okay, so here we'll look at the slope of the tangent. So if you remember, the slope of the tangent line is represented by the equation m is equal to the limit as h approaches 0, and here we have x plus h, the function of x plus h, so here it'd be c 400 plus h minus the function at the value of a, so here it's c at 400, all over value of h. Okay, so we know that here the limit as h approaches 0 for c 400 plus h, so we can rewrite that as 500 plus 2 square root 400 plus h, and we saw that at c at 400 was 540. So we'll subtract that by 540, and that's all over the value of h. So here, if we combine the 500 and 540, the limit at h approaches 0 of 2 square root 2 square root h plus 400 minus 40 over h. And here we'll multiply by the conjugate radical, which would be 2 square root h plus 400 plus 40. And what we do to the numerator, we'll do to the denominator. So we'll multiply the bottom by the same. So 2h plus 400 square root 8 plus 400 plus 40. What that will leave us with is we'll have the limit as h approaches 0. We'll be left with 4 bracket h plus 400 minus 1,600 over h times 2 square root h plus 400 plus 40. So here we can expand 4 to h and to 400. Here we'll have limit as h approaches 0, 4h plus 1,600 minus 1,600. Those cancel out, all over h bracket 2 square root h plus 400 plus 40. So we'll rewrite this. Again, limit as h approaches 0, 4h over h bracket 2 square root h plus 400 plus 40. Here we can cancel out the h. And so finally we'll be left with 4 over 2 square root h plus 400 or 0 plus 400. So 400 plus 40. If we just go over here, our slope, as we calculate this, will be 4 over 2 times 20 plus 40. So that gives us 4 over 80, which simplifies to equal to 1 over 20. So what does that mean in terms of our question? So when the company therefore when the company publishes 400 catalogs, the cost increases by 1 over $20 per catalog. Okay, so now we're going to review a couple of things about lines. We understand that the slope of a line we can write as m is equal to delta y over delta x, which is also equal to y2 minus y1 over x2 minus x1. And the slope of a tangent line, the formula that we use, is the limit as x approaches h, limit as h approaches 0, sorry, f of a plus h minus f of a over h. You know that the slope y-intercept equation of a line is y is equal to mx plus b, m being the slope, b being the y-intercept. We know that with parallel lines, these slopes are equal. Perpendicular lines, we know that these slopes are the negative reciprocal. And what that means is, for example, you have a minus b. The negative reciprocal of that is negative b over a. For horizontal lines, we understand that the slope is equal to infinity and y is equal to b. And for vertical lines, it's undefined for the slope. And so what that really means is there's an infinite slope and the x value equals to the x-intercept. And then the standard equation of the line, if you recall, it is ax plus by plus c is equal to 0. Ax plus by plus c. A has to be greater than 0, and b and c, a, b, and c are all integers. So here, let's look at example number 2. It says, find the equation of the line through -1, 5 in parallel to the tangent line to the graph of f of x is equal to 5 over x plus 1 at the point P, 4, and 1. So again, it says parallel to the tangent line. So what we can infer here is that the slopes are equal. So the slopes are equal. And what we want to do is we want to find the slope of the tangent line first. Okay. So we know that this function, 5 over x plus 1, has a point at 4, 1. So let's sub in x is equal to 4. So f of 4 is equal to 1. So if we sub that into our oh, here again, sub f of 4 into 1. So 5 over x plus 1, or 5 over 4 plus 1 will give us 1. And if we sub in f of 4 plus h, that'll give us 5 over 4 plus h plus 1, which is equal to 5 over h plus 5. Okay, so let's find the slope of the tangent line using our equation. M is equal to the limit as h approaches 0, 5 over h plus 5. That's from our 4 plus h, f of 4 plus h, and minus f of a, or here f of 4, which is 1, all over h. Here, what we want to do, multiply by a lowest common denominator, which at the top is h plus 5. And so if we multiply h plus 5 to 5, that would be 5. And multiply h plus 5 to -1, we'll get negative h plus 5. So here the limit as h approaches 0, 5 minus h plus 5 over h bracket h plus 5. Okay, so here we have the limit as h approaches to 0. We can rewrite it now as 5 minus h plus 5 over h times h plus 5. So the lowest common denominator here is h plus 5. Here, if we simplify this, the limit as h approaches 0, 5 minus h minus 5, 5 negative 5 will cancel out. And at the bottom, we're still left with h plus 5. Rewrite that, we have the limit as h approaches 0, negative 1h over h plus 5 The h's will cancel out, and we'll be left with -1 over h plus 5, or -1, or -1 over 5. So our answer will be -1 over 5, because we subbed in the 0 for h. And now it says us wants us to find this equation. Okay, we know that it's parallel, which means that our slope is going to be the same. So y is equal to mx plus b. Y is equal to -1 over 5x plus b. Okay, and now we're going to sub in, and it passes through the point -1, 5. So we'll sub that in to this equation. So sub -1, 5 into equation. So 5 is equal to -1 over 5 times -1 plus b. 5 is equal to 1 over 5 plus b. B is equal to 5 minus 1 over 5. B is equal to 24 over 5. And therefore, we can write that our equation of this line parallel to the tangent line will be y is equal to -1 over 5x plus 24 over 5. Okay, let's move on to example 3. It says, determine the coordinates of the point where the function f of x is equal to 7x squared minus 2x has a tangent that is perpendicular to the line x plus 5y minus 3. So we know that perpendicular means negative reciprocal. In terms of slopes. And here, again, it has a tangent from this function, which means that we have to find a specific point a and f of a. So here we need to find point a and f of a. Okay, so let's first determine the slope of the perpendicular line. So again, this is in standard form, so let's convert it into slope y-intercept form. So here we have x plus 5y minus 3 is equal to 0. Move everything over except for the y. So we have 5y is equal to negative x plus 3. Y is equal to -1 over 5, x plus 3 over 5. And so if we know, so here, what we're doing here is we are determining the slope of the perpendicular line. Okay, and if we know that the slope of this line is -1 over 5, the, the perpendicular slope equal to 5, because it's the negative reciprocal. So here you see that our slope is equal to 5, and this is because the slope of our tangent slope of the tangent is the opposite, is the negative reciprocal of -1 over 5. Okay. So then the next thing we want to do is we want to find again the point a and f of a. So again, we use the limit formula here to solve for the a value for the x coordinate where the point where of the point where the tangent touches f of x. So let's write our formula and we'll see how we do this here. So here we have m is equal to the limit as h approaches 0, f of a plus h minus f of a over h over h. So here it's a little bit different because this time we actually have the slope. We're going to sub that in. So m is going to be equal to 5 is equal to the limit as h approaches 0. And here we know that our function, so f of a plus h, so we'll sub that into our equation 7x squared minus 2x. So here we have 7 a plus h squared minus 2a plus h minus 7. So this is 7a squared. So this is f of a minus 2a. Okay, that's all over h. Here we see that 5 is equal to the limit as x approaches 0. And so if we expand this, we'll get 7a squared plus 2ah plus h squared minus 2a, so expand that, minus 2a minus 2h minus 7a squared plus 2a. Okay, and that's all over h. Okay, so let's expand the 7 into each of these components here. And so here, 5 will be equal to the limit as h approaches 0 of 7a squared plus 14ah plus 7h squared minus 2a minus 2h minus 7a squared plus 2a all over h. And so here we can see that we can cancel a few things out. You see that here there's 7a squared, negative 7a squared, that cancels out. Positive 2a, negative 2a, that will cancel out as well. So now if we rewrite this, we have 5 is equal to the limit as h approaches 0, h over. So here we have, if we factor out an h on everything at the top, so we factor out an h, we'll have 14a plus 7h minus 2. So that's if we factor out an h from all the components at the top. And we'll divide that by h. Here we see that h can cancel out. And here, if we sub in h is equal to 0, so this would be equal to 0, then we'll be left with 14a minus 2 is equal to 5. So let's move up here. So here, 14a minus 2 will be equal to 5. Move 2 over, we'll get 7 is equal to 14a and a is equal to 1 over 2. So now we found that a is equal to 1 over 2. We can sub that back into our equation to find the corresponding y value in this equation, or f of 1 over 2. So here, let me just write what we did here. So we use the limit. So use the limit formula to find or to solve for the a value. Or we can also indicate that as the point, or the x-coordinate, where the tangent touches f of x. Okay, so let's continue on. Again, we have a is equal to 1 over 2. So now we're going to sub that back into our equation. So here we have f of 1 over 2 is equal to 7 times 1 over 2 squared minus 2 times 1 over 2. That'll be 7 over 4 minus 1, which is equal to 3 over 4. So here, again, we just subbed in the value. So let's just indicate what we did here as well. So we subbed in the value. So sub in the value of a in the equation. F of x is equal to 7x squared minus 2x to find the corresponding y value. Okay, so here we know now that the coordinates of that particular point that we're trying to look at is at 1 over 2 and 3 over 4. Therefore, the coordinates are 1 over 2 and 3 over 4. Okay, so let's look at this last question here. And it says, determine the equation of the tangent line to y is equal to 1 over square root x at point 4, 1 over 2. So first thing we want to do, sub in before, and that equals to 1 over square root 4, which will give us 1 over 2. Now we'll sub in f of a plus h here, which is 4 plus h, equal to 1 over square root h plus 4. And so now we'll sub that, because we're finding the equation of a tangent line, we'll sub that back into our equation. So m is equal to the limit as h approaches 0, 1 over square root h plus 4 minus 1 over 2 over h. So here, what we want to do is we want to simplify using a lowest common denominator. So just a note here. So, so again, first simplify using lowest common denominator, then use conjugate radicals to solve for the limit. Okay, so here we see that our lowest common denominator will be 2 square root h plus 4. So here we want to multiply this by 2 and multiply this by square root h plus 4. So what we'll be left with here is we'll have m is equal to the limit of h approaches 0. And here we'll have 2 minus square root h plus 4 over 2h square root h plus. Okay, now we can multiply by the conjugate radical. Here will be 2 plus square root h plus 4. On the bottom will be 2 plus square root h plus 4, which will help us simplify this equation. So here we have the limit as h approaches 0, and we'll be left with 4 minus h plus 4 over 2h h plus 4 times 2 plus square root. Let's rewrite that actually. So we have 2h square root h plus 4 multiplied by 2 plus square root h plus 4. And so here we will expand. We'll get the limit as h approaches 0, 4 minus h plus 4 over 2h square root h plus 4 times 2 plus square root h plus 4. Here we can cancel the 4, be positive 4, sorry, and then here it's going to be minus 4 because we multiplied negative in. So positive 4, negative 4 will cancel out. H will cancel out from the bottom. So we sub that in. Now we sub h is equal to 0. We'll be left with negative 1 over 2, 0 plus 4, or 2 square root 2, or 2 square root 4, bracket 2 plus square root 0 plus 4, which again is square root 4. If we simplify that, we'll have negative 1 over 4 times 4 is equal to negative 1 over 16. Okay, so now that we got that the slope, we have to now find the equation. So we have to find the b value. Here we have y is equal to mx plus b. Y is equal to negative 1 over 16 plus b. And we are going to sub 0.4, 1 over 2 into the equation. Sub it into the equation, we get 1 over 2 is equal to negative 1 over 16 times 4 plus b. 1 over 2 is equal to negative 4 over 16, which simplifies to negative 1 over 4 plus b. Add 1 over 4 to both sides. So 1 over 2 plus 1 over 4 is equal to b, and therefore b is equal to 3 over 4. So finally, our equation here is y is equal to negative 1 over 16 plus 3 over 4.